So it's pretty cold out there. That easterly wind is vicious. You don't want to be standing in it. Anyway, a few days ago I was putting up some wall cladding, screwing it in place, and I was using an impact screwdriver that I'd fixed quite a few years ago now, and it's a Makita with the standard Makita batteries. What are they? BL1830, 18 volt. Yep. Anyway, this one, brilliant. Yeah, and we were going well and everything, we weren't rushing, yeah, and suddenly it went I thought, here's the core out of it. Now, you may remember that I did a video about these where there's a chip on board which does some form of counting or other and switches off. So I've got several of these, and most of the time, or all of the time, I charge them up with the bench power supply on limited current and limited voltage, 20 volts at something like 200 milliamps, and then you can leave them on there for ages and they will just stop charging, and that gives it a good chance for all of the cells to equalize. Great. I've not really had much of a problem with that, and of course the main thing to remember is don't just take him down and down and down, just sort of use it for half a day and then charge it up again. Great, yeah, no worries. So there's a few weird things happened with this one, so let's just sort of bear in mind it's been repaired at least once before, but let's zoom down, and this is something interesting that I've never come across before. Okay, when I went to charge it on the bench power supply, it would only take like 2 or 3 milliamps. Immediately I was suspicious. As I say, check the voltage, 18.2. Well, you know, to get these fully charged they want to go up to 20 volts. Bear in mind it's switched off, or it stopped, or it did not provide any more power. So then we go cell 1, fine, yep, and not wrong with that. Wants to charge, cell 2, is that right? Yeah, that's right. Cell 3, yeah, bit uneven. Cell 4, yeah, not a problem. Are we there? I think we are. Yeah, I've got this the wrong way round. Right, let's start. So that is the, I think that is the negative. Okay, so cell 1, 3.6, good. From there to there, cell 2, 3.6. From there to there, cell 3, 3.5. Okay, so then this brown cell, because that goes across to there, is, let me just get that right, got to get a good connection, 3.8. okay, and then from that one there you go across to this one here, which 3.7. You think, right, they've all got voltage, but one of them, or maybe several of them, are misbehaving. But how can I identify the ones that are misbehaving? Don't know. Yeah, because you know, I'm basically on the basing all this lot on the fact that it actually just went stop working. Right, so what we've got here is a test lead with, where are we, a couple of crocodile clips on it. It's a dead short, right? Okay, so let's try this. Did you see that? Yeah. So that one's alright for current. This one, yeah, that one's alright. This one, yeah, there's some current. The brown one, nothing. The end one, yeah, there's current there. So that one, that brown one, or whatever colour it is, yeah, is just not producing any current whatsoever. So I think that that is the duff one. Now, I've never come across that before, but what I'm going to do is I'm going to desolder that and this end and dig out some cells. I'll probably use the cells that these cells here that came from that pack of Lees. Do you remember that from the Hitachi? They're 2.5, so they'll be well powerful enough. And I will, and this time I will spot weld them in place. So you can see that I repaired this quite a long time ago because it's soldered. Now I will spot weld them, and I will just get back to you when I've done this, and hopefully it'll be a serviceable pack again. So I've taken those brown, green, whatever colour they are out, yeah, and to get them in I've had to just split that. This was a pair of cells out of this, which is that diesel tank pack, the ones where the battery management system was gone. I didn't want to use the ones from Lees because these other ones are 1.5s and the ones from Lees are 2s, so therefore we would have a disparity. I need a block of wood. So these are those two batteries that I removed. Of course they were in parallel and 3.9 volts. Yep. And the other one, got a bit of a problem with connection there. Yes, only 1.1 volts. So one of them was duff and the other one was obviously pulled low by the duff one. Hence there was no current from these. There was voltage but no current. A bit strange actually, and I'm not sure whether I can do any further tests. Let's just see if this is a, where are we? An indicator bulb. So if I wrap the connections to that indicator bulb around the probe, hopefully we're getting a half decent connection. Let me just zoom out a bit. Yeah, so we'll hold those there. We've got a theoretical load on that. Yeah, so we put a load on it and there's no volts. We take the load off and we've got the volts. See, 3.8 volts is theoretically fairly well charged, but you put a load on it and the volts disappear. Very strange. See, there you go. And of course the bulb represents a resistance, so therefore it's not a dead short, but nothing's flowing. Okay, we did well to isolate that and remove it. that looks about right. So first of all, this is going to be a bit weird. Okay. Let's do that again. Good. Excellent. So now I want to put a link between there and there. And I've got some new nickel connector. Better to cut these with the scissors really, but the shearing action seems to work better. But that's a nice flat area there. Hopefully you can see all this and my arm's not getting in the way. Yep. I think maybe we can just do one more there. The secret of this is not to have the battery too charged up. I do have a video about this. Hopefully I will be able to, or I'll remember to put a link in. So now we need to go, we've gone from there to there, we come through here and we go from there to there. I actually replaced the last lot of cells as well because the soldering was annoying me. Right, where's that gone? I can see it. I'd obviously had trouble soldering it and it was rather blobby. I thought, right, now's the opportunity. Those other cells were out of that one of those cordless Hoover. That doesn't want to. There we go. That was a good zap, wasn't it? Okay, so now we need to connect there to here somehow. Yeah, it's all a bit manky, isn't it? Where are we? I think I need to just flatten that out. And then we need a piece of this that goes from there and bends over. Except this time I'm not going to let it go flying. So we go from there and we bend over and we go down there. So we'll just need to, well, sometimes these are just rather tough, and other times they just cut quite easily. There we go. Grand. Right. So we go on top of that connector there. and that way. So what's shorted out then? Just on there. Let's put a bit of tape on there. 1 minute. So I've got a bit of foam tape insulation there, that's better. Because one of the problems with these cells is, especially on the positive end, right, is that's the positive, that is the negative. So it's not very far, is it? So this tape, and on the positives there should be either a cardboard or a foam ring. They're really important. Otherwise you've got positive and negative right next to each other, and you get exactly what happened there. You get a little bit of an excitement. Right, so that's spot welded together. Now, can I spot weld this together? Has it spot welded together? No, it hasn't. I'm going to try again, but it may be that we might have to solder that. You just have to excuse if you can't see, because I'm doing tricky stuff here. No, it didn't. Let's push this over there. Oh yeah, grand. I've got it. So we've got the positive there, and it's soldered there, and it comes to this buzz bar or connection underneath there. And so what I've had to do is, because I'd previously soldered this and it was all bent and got solder on it and all sorts of things, I had to remove the tab that normally came down there. So we made a fresh one, and I've just spot welded it just inside. If I'd have had more problem, I've had to grind away a little bit of this plastic to get to a bit more of this connector here. But as it happens, it's worked, which is grand. Right, a little bit of chaos there. So we've got the meter here. Put it on a block so we can see. Yep. So we've got cell 1, cell 2, cell 3. Let me just get to cell 4, cell 5. That, I believe, is the positive, and that's the negative. We've got 18.2. Okay, so nothing has changed as yet, but from one end to the other, yeah, we've got power now. Okay, hopefully you find that entertaining and maybe learnt a bit. Yeah. It's that whole problem of the positive and negative being so close together. You've got to be super careful. But, you know, they go, oh, don't short a lithium battery out. Don't short it out like, but if you just want to tap it just to make sure there's some current, this test that I did has proved something. And spot welding these together, yeah, just make sure the battery is not fully charged. Makes a huge difference. There you go, lithium smoke and mirrors. Yeah, another one fixed. I mean, fixed to my standards in so much as the board is still faulty, but you know, I can make this last for years. And Why do I make it last for years? Because then I'm not consuming more new products. I'm keeping the old ones alive. Yeah. So loads of comments, please. Yeah. Yeah. Because, you know, it's investigation, isn't it? So I'm interested, you're interested, I want to hear what you think. Yeah, if you haven't already, subscribe and like and all that nonsense, and I will catch up with you real soon. Cheers for now.